Me just the bare bones of SDN. What's the concept behind SDN?
Controller.
Right, a central controller. So that's one concept. What else? How do we accomplish that? Like, why do I need a central controller?
It's like one place to, do all your settings and yeah.
That's true. So why would I do that when my devices can control themselves?
Doesn't it help streamline where before we had multiple servers, we can do a bunch of VMs on a couple of servers to get the same type of effect out of it all, right? Less product, less
So
surf.
something happened that resulted or made us need to use a controller. So what did we do to the devices that made us start to use a controller?
Maybe updates.
No, that's not what I'm looking for. I separated something from something.
Separated the control plane from the data plane.
Yeah, exactly, right? So we separated the control plane from the data plane, which is why we need the controller. Because now, Sean, like you said, now we use a controller to do that, right? Now, if you read through this, so we already went through a lot of these, right? We kind of got the basics of SDN, right? We went through this, how we've separated the control plane and the data plane. Now, there's different versions of SDN, right? Some of them have gone completely controller based. Others are where you've added software onto your devices and then you can control them that way. And then you've got APIC-EM. APIC-EM is the enterprise model, again, where it's Cisco's version of an enterprise being able to keep their routers and switches. And so they're really not, APIC-EM doesn't completely separate the control plane. So their devices really continue to make decisions, right? So it's a little bit different. So you've got like here in this picture, we have the traditional network, we've got an SDN architect network, and then you have an APIC-EM network, which again is a little bit of a different iteration of that. Okay, so we went through these. Okay, so I think we kind of stopped around here. Okay. So it just breaks up a little bit more the two different types of architectures that are developed for SDN. You've got the traditional SDN, and then Cisco has come up with their own version. Actually, Cisco has two versions. They had an original just straight up SDN network, the ACI, and then they went from ACI to APIC, and then they went from ACI to APIC to APIC-EM. Now they're all available. They still sell all of those solutions. Okay, so the traditional software defined network is again where I've separated everything. I'm going to use, so OpenFlow is considered an architect or a platform. Okay, but OpenFlow is also the name of the protocol and the API that pushes the programming down to our devices. Okay, so another thing to me that's a little bit confusing is the terminology is sometimes used in multiple ways. So a good example that we're familiar with is the TCP stack, right? So we could be referring to the TCP model as in the 4-layer model, or I could be referring to TCP as in layer 4, the transport layer. Well, that's kind of like OpenFlow, right? OpenFlow is a platform, it's also a protocol, and it's the API. Okay. And then we've got the ACI, the Cisco application-centric infrastructure. So Cisco kind of went about things a little bit different in the sense that they reverse engineered it and they thought about things from the application. And if you think about an API, it's a little program. That's kind of how our phones work. So when you pull up your phone and you have an applet, you've got like the little tile to access an application and you push that tile. It's an API that's going out and grabbing the information in order to open up a game or to open up an ordering app. Okay, so that's a little bit of how an API works, okay? Now, Cisco's ACI uses something called OpenStack. Now again, OpenStack is nothing more than the platform or the environment. OpenStack isn't really referring to an API, although there are several APIs that work within OpenStack. So if you've built an OpenStack network, a Cisco ACI, and you've built an OpenStack platform, then there are particular APIs, northbound and southbound, that would be compatible with that platform that you've built, okay? So again, we are just showing a picture here how we've moved from the standardized network that we're used to, and we've separated the control plane, and we've pushed all of that work into the controller. So remember, what the controller is doing is it's basically managing data, building tables and stuff like that. And so it will have data up here, right? And now let's say this is a switch down in our network device. Our switch is no longer going to be making the decisions, but the controller has pushed a table down here. Now it pushes the data down into the data plane, but the switch does the work. The switch moves the frame, or in this picture, it's a router and it moves the packet, okay? So again, that's how the controller is doing all of this extra work. Now, what has made SDN possible is something called an ASIC chip circuit, which just means it's an application-specific integrated circuit. I don't know if the book talked about an ASIC chip, but essentially, whenever you have a specialized device, it's got an ASIC chip in there. So that is a technology that has evolved that's allowed us to create specialization on a circuit board, on a circuit chip. And they're tiny and we can embed them so they can take on special jobs, okay? So a northbound and a southbound interface, something to keep in mind that when we are talking about SDN, we're not talking about interfaces in the way that we are used to talking about interfaces, because up to this point, we've always meant a port, right? We've meant we were either talking about a port on a router, or maybe we were talking about an interface on a switch. Well, what we're talking about when we're talking about SDN is something that's interfacing with the device, and it's the program, okay? So we've got a northbound interface and we have a southbound interface. So that just means programs that are set up that can interact with whatever the device is. Now, a controller is a physical device. However, the most important piece of the controller is the software that you've put on there. So really, when we're talking about an SDN controller, we're actually really talking about more the software program that's on there that's allowing us to do this network management, okay? So the southbound interface is referring to the network devices below the controller. So with this picture here, if you notice, this says southbound interface, right? So these would be any type of programs, APIs, that are interfacing between our controller and our physical network devices. Keeping in mind that our physical network devices might be virtual machines. So maybe they're not physical, they could actually be virtual machines, okay? Then the northbound interface is opposite. It's what's going from the controller up to the application, okay? And the application is typically going to reside in a cloud, in a data center, you know, and that could be a private cloud, could be a public cloud, however you've set yourself up. Okay, so this is what enables the applications and orchestration systems to program the network. So these northbound APIs are more like policy-based type of APIs. What is my security policy? What is what's my bill pay system, right? What is our HR system? So we'll have applications that have policies set in them. And so the controller can get directions from the policies, make decisions based on the information that it has in its controller. Then it pushes that down to the southbound devices. Now, what could happen is the southbound devices can share information back to the controller. The controller can push that information up to its applications, and then the application policies can make additional decisions or rework something, change a policy, add a policy, or just say, okay, this is working great. This is what we're going to keep doing. Okay?
I have a question.
Yes.
Okay. I'm a little confused. I understand that it's a device that sits on the network. That's simple enough. Is this something that sits in the midst of the traffic, or is this a control device that's sending and receiving signals and controlling traffic flow? Does that make sense?
It's actually, it depends which one it is, but it's actually controlling traffic flow. It is making, it's making decisions about the traffic flow based on what its security policies are. And then it's telling or giving directions to the network devices. Based on this policy, you will allow this or not allow this. Or based on this policy, you will push, you will forward that type of frame or not forward that type of frame.
But it's not like an F5 that would sit right smack in the middle of all the traffic and do all the routing and switching and on itself.
Nope.
Okay, now I understand. Cool.
Yeah, it's not. It's different because so we've actually, because that is functioning more like a, I don't know, like a routing device, right? So
Sure it is.
yeah.
Okay, cool.
Yeah. Okay. So let's watch this video. It's very short. It's about the northbound and southbound APIs.
What are northbound and southbound APIs? And what role do they play in SDN? Let's take a look. In software-defined networking, centralized controllers talk to network devices about how they should handle traffic. This back and forth between the controller and the forwarding devices happens through southbound APIs. The network controllers also talk to network applications that define what kinds of services the network should be providing. This communication happens through northbound APIs. Southbound APIs communicate information from the devices to the controller about things like available links, supported functionality, and interface states. For instance, if something goes wrong with the device, it will alert the controller so that adjustments can be made. In the other direction, the controller pushes rules to the devices telling them what to do, based on information from the applications on what services the network should provide, and information from the devices about the current state of the network. These southbound APIs can be open or proprietary. Some examples are OpenFlow, NetConf, or SNMP. So what about the northbound APIs? Just like the device that communicates their status to the controller will use the northbound APIs to present the state of the network services to the relevant applications. If an entire service is unable to work, for instance, the controller will inform the relevant application to process as appropriate. Northbound APIs are controller-specific, such as policy APIs, billing APIs, or security APIs. So applications are written for one specific controller. In the other direction, apps will request network service changes from the controller using information from users on what they need, along with information the controller provides about current capabilities. What does this look like in practice? Let's use a simplified example. Imagine that there is a security application responsible for keeping certain malicious traffic from entering the network. This app has detected that a particular device with IP address 1.1.1.1 should be prevented from accessing the network. The security app will make a request to the controller on its northbound API to block IP 1.1.1.1 from entering the network. The controller will then use its understanding of the network state to translate this request into specific rules for relevant devices on the network and communicate that with the devices using the Southbound API. So it might push out rules on the Southbound API to device Z on the network, telling it to block any traffic on a specific port with source IP 1.1.1.1. Once IP 1.1.1.1 has been blocked, device Z reports this to the controller, which reports back to the application that the task has been completed. If the state of this interface were to change, that would also be communicated through the controller to take appropriate steps to continue to block elsewhere, or potentially to report the service issue to the security application. To learn more about this and related OIN topics, go to OIN, which reports back.
So did you notice something here? So when something happens here, where does router X report it to? The controller. In a traditional network, if router X, Y, and Z are all connected and running EIGRP, who do they report to? They share information, same goes with switches, right? Normally switches that are running STP, like spanning tree, right? They're sharing their BPDUs. Well, in a controller environment, all that information is going to the controller. Then the controller is pushing information to the other devices about what's happening on the network.
So the controller is like one interface that allows me to access all of the routers.
Yes.
Each router then like in this picture, there's 3 routers. Do they all act as one, or have I got to integrate or log into each one individually through that one interface?
You do everything through the controller. You don't log into each one individually. Now,
That's pretty cool.
From the controller, you can give them different jobs, right? You can tell them to do different things. So
Virtual machines.
we used to teach something called VTP, okay? VTP is a way to centralize management of switches. So it used to be that you could have 20 switches and you'd create like a master switch. And that switch is the switch that you give all of the commands to. And then that switch talks to all the other switches. So when we taught VTP, it kind of was a segue into SDN, because SDN is similar in the, like, just conceptually, it physically isn't working the same way. Its computations aren't the same, but again, just conceptually, that's what's happening. So we're doing and the controller, it's CLI based or GUI based. So like if you're talking about APIC-EM, APIC-EM is all GUI, and you don't have to even use APIs. Whereas like with OpenFlow and OpenStack, you do have to have an understanding of APIs, or you'd hire a person who will write your APIs. They'll be writing your little scripts in your programs on how to manage this. Now, an API could be giant or it could be smaller. Like, did you notice how they said here, these are controller specific, right? Now, there is standard APIs for, if you have a billing system, but like the healthcare system, as an example, they have a special set of needs for a particular API and different types of apps and different things like that. So, they're going to be more specific to the job. So like that's a whole job, writing APIs, which is one of the reasons why there's always this need for, programmers, because of the way APIs are they're doing everything now. I mean, everything is like look at our cell phones, right? That's all API based. Our TVs, everything is API based. So that's why there's a demand for programmers a lot of times, because they're writing APIs. And then, and there's API kits. So like I've written an API before. I mean, you can go and write your own API and create your own app, right? And because now there's relatively, I think Cisco's is called 1PK or something, but Java has APIs. I mean, everything has APIs. Google has APIs. Etsy, which is like a selling for artists, right? So you can write APIs for different things. So, yeah.
So we're going to have to get into writing scripts.
Yeah. So that's really what like the next module, network programmability.
Automation.
I don't know if they like I will say I'm really surprised that as part of our new curriculum, what we're doing right now, right? I was shocked that we were not having to learn basic Python scripting, which is why I tell all my students take a Python class, right? You just either learn C++ or Python because it's the most common languages for writing scripts. You do not need to become a master programmer. However, it's a good idea to have some basic scripting skills because of this, right? So even if you are not doing full SDN, we're still doing more and more scripting and networking than what we ever used to do. And again, that this is literally changes on a year-by-year basis. I mean, even 5 years ago, it wasn't as common as it is now, which is why we are seeing this whole module and module 14, the next module, added in because of the way that it's changing. Yeah, and now I don't know. I'm not going to say that I hate programming. I don't hate it, but because I've never had the time to get good at it, I don't love it. But yeah, it's something that you have to have a little bit of ability in. So again, if we look at this, right, this right here would be considered like a northbound interface. So I have this app up here, which is being stored someplace. And then I've got the API interface so that it can recognize it. It knows that it's talking to it, right? Same goes here. It knows that it's talking to it, and then vice versa. So I've got something on this router. I have some software on the router so that if I'm using, say, OpenFlow Southbound API, when it receives that, there's a program interface on that router that's like, oh, he's talking to me. That message is for me. I recognize that. Okay. Does that make, I thought this was one of the better ones for explaining, again, northbound and southbound APIs. And is OpenFlow a northbound or a southbound API protocol found? Right. So it's a program, OpenFlow. It was created by the Open Network Foundation. So SDN started out as an open source platform, right? So a bunch of companies got together and said, hey, let's figure out how to automate our network. So Cisco, Google, Yahoo, I think Microsoft, I mean, a bunch of Linux, right? They all got together and started kind of working on how to do this. So OpenFlow, again, it's thought of as a platform, a protocol, and a little program, like the program that communicates. So you would be running the OpenFlow protocol on your end devices, so your router or your switch, so that if it receives an API, an OpenFlow API message, a program message, or a script, it can know what to do. And so that's running between your controller and your end devices, okay? So if we look here, so we would implement OpenFlow on the controller interface. Now, not the physical interface of our controller, but basically on the operating system, right? We install it onto our controller. Same goes here. We're going to install OpenFlow protocol so that it can communicate back and forth with my controller. And each of these devices will be running OpenFlow. Okay, so OpenFlow is a southbound API. It allows communication between the controller and our network devices. Now, other southbound APIs, there's a ton of them, okay, is NetComp. Now notice here SNMP, right? SNMP is considered a southbound API because if I'm using APIC-EM and I think even ACI, I can use SNMP because remember we've got the gets, the sets, and the traps. So I'm being able to share information back and forth between my controller. So if you remember with SNMP, we have to install the software on the client device as well as the hosting device. So SNMP can function in an SDN network. Southbound interfaces. Interface here, okay, we've already said that refers to the software program interface, not a physical interface. The southbound interface is referring to the network devices below the controller, but we're not talking about the specific port. We're just talking about what's been installed from a software perspective, okay? And then notice here, API, it's allowing one application to exchange data with another application between the two. Okay. That makes sense now about the southbound APIs. Northbound APIs work the same. They're just, except they're going the opposite direction. They're moving above the controller, okay?
Bi-directional.
What's that?
And they're bi-directional. They may be southbound, but they come back and forth.
Good point.
Controller
Yeah, and that's true for both the northbound APIs and the southbound APIs. So we're really just referring to the direction based on the control, like are we going down or up based on the controller, right? And then we're just talking back and forth. Oh, okay, then there's just that same picture we were talking about that we saw in the video. Again, notice here, depending upon what my company is, I'm going to have a specific policy. Now, these policy APIs can be all different things. They can be AAA, TACAS, they could be who's allowed on my network. It could be specific. I could write an API for the type of training that my company requires new employees to do. It literally can be anything. It can be anything at all, okay? The SDN controller is using the northbound APIs, right, to communicate upstream. Now, where are these apps being held? Who knows? They could be held, in your own data center, a cloud, IaaS. You might be doing infrastructure as a service, right, or platform as a service, and they may be hosted there. So they could be hosted anywhere. Again, kind of like, I don't know if this is the best analogy, but if you've got an app on your phone, okay, you have Five Guys app, you have Scrabble app, okay, whoever those companies are, they are hosting their app in whatever cloud service that they subscribe to, okay, or whoever they've paid to build their app, right? So that's where it is. It's the same with this. It's wherever I am subscribing to host my services. And then how it relates to cloud is like, is it cloud-based? And then is it infrastructure as a service, platform as a service? Do I have a community cloud? Do I have a private cloud? So traditional and SDN architectures. So the other thing I don't think this job does this chapter didn't really do a great job of explaining, nor am I able to completely explain. However, your controller, if you're running SDN, your controller is where you're probably going to be putting your QoS, okay? Because you're going to want to be implementing QoS potentially in here. So if you notice this says helping network administrators shape traffic, right? QoS is part of what helps us shape traffic. So this is another reason why SDN is more likely to be in a large enterprise. Well, again, enterprise meaning a company, right? So maybe I have a location in Phoenix, I have a location in New York, and I have a location in Tokyo. That is all my enterprise. But SDN is a product or a technology that's more likely to be implemented in larger companies, larger applications. SDN isn't something that your small three building with, 2 routers is going to necessarily, you're not going to implement SDN like that.
Graphically spread out.
Yeah. I mean, it's because the cost associated with it would really go up. So, which is another reason why, you may or may not be working with SDN when you first go into the market, right? It depends what size company you're going to be working for and what they do and how they manage their infrastructure. See, okay, again, just another picture here, right? Here is our SDN controller. The reason it says routing right there is because it is making the decisions. But remember, it makes the decisions and then it uses the Southbound APIs to push that information down so that the routers and the switches actually do the job. Let's see. So the way I see north and south traffic is if information is coming in or out of the network. No, it's not really in or out of the network. Northbound and southbound is more communications in your network. Because northbound and southbound isn't talking about a packet or a frame once it leaves your network. And it's not necessarily talking about what's coming into your network until the networking device gets data. Okay, so if I have a frame that comes into a switch from a remote, it's not going to be a remote network at that point, but it's coming from Pennsylvania, comes, right? So remember, it's encapsulating and de-encapsulating the IP packet, the IP address, the source and destination are staying the same, right? All through the network. And then it hits my network. It hits the router. So then it's going to de-encapsulate the MAC address, all right? So then that's going to go into my MAC address table on my local device. Now that data, an API, a Southbound API, will be used to gather that data, push that data up to the controller. The controller makes decisions based on policies. Then it tells the switch what to do with it. Okay, so northbound and southbound APIs are only affecting your own network, not traffic that leaves your network, not traffic that's coming from a remote network in. It will affect it once it's within the network, but SDN is only applied to your own enterprise, your own domain. Explain more, Chris?
But yeah, it was how like information is, if it, because the way that I see it is like, if it's southbound, it's taking all the application information and sending it to the router and switch. Is that right? Kind of, sort of. If it's coming from like outside of a net well, not outside of the network. I'm trying to think of how to phrase the question.
So up here in the applications, so let's say this business application is a security policy about the way that we manage HTTP traffic. Okay, so I, as the network administrator, has decided that there are certain websites that will not be allowed to be accessed, or we will not allow information to come in from that website. So I develop that policy, and then I write a little program, an API, a northbound API, and I tell the controller about that. And the controller, so again, this is only within my own network, what I have control over. And because this is think of this as the higher end, the top end of everything, right? And notice how
the application tells your controller what to do, and then it applies the service.
Yes, then the controller says, okay, in order for us to do that, I need to tell my routers and switches what data they're allowed to forward, what data they have to drop, etc. So the controller receives the information based on data that it makes decisions about and controls, and it can see, because the controller is kind of looking at everything. It can see everything because remember, everything is communicating with it, okay? So in old world, right, this communicates with that, then this communicates with that. Well, this will share information about this. Our router X has to learn about router Z because it's dependent upon router Y, right? So when our old-fashioned way, we can see the topology. The routers can figure out the topology because they're sharing a bunch of information with each other. Okay, but the truth is they really only know about their neighbor. They know about remote networks because they learned about it from their neighbor. Here, there's an all-knowing eye that's looking and seeing everything. And so the concept or the thought is it can make better decisions, quicker decisions. It can implement security better and faster. Okay, so again, that policies come down about HTTP traffic. It knows everything because of where it's located. Now it pushes that down to the routers and switches, and it's like, okay, guys, hey, you're not going to receive traffic from here, and you're not going to send traffic to there. And then this will send a message, okay, got your message. But everything's happening within my own domain or my own platform, like my own OpenFlow platform, my own OpenStack platform, whatever my infrastructure is. So a controller is a physical device and it has software on it. Now, in some circumstances, it could be anything. It doesn't, so there's different implementations of SDN. Some implementations of SDN require specific devices, like the Catalyst 9000 series. Okay. Some implementations of SDN just require software to be loaded onto a device. And then the APIC-EM or ACI, that can run on anything. You do need to have one specific device. You have to have a specific controller running a particular type of software, but then you can continue to use all of your routers and switches. Okay, so it depends. You would look at your network and say, well, how much money do I want to spend? What do I really need to do here? And that's what would help you decide what version of SDN you're going to run. I have to move my chat box around because it covers stuff up. So we're going to talk a little bit more about the controllers and its operation, right? So we already, yes.
Yeah. So is this SDN SDN technology limited only to switches and router stuff, or does it also apply to like controller hard drives, where they would separate out a controller from a single drive and span it across multiple drives, like for a RAID situation, for instance?
So like servers, right? It can apply to servers. Now, I don't think SDN will go down to an end device, because that end device, at this point, right, I think that's going to change, but an end device still needs to make decisions, but it can apply to a server, routers, switches, layer 2 or layer 3. Let's see. Trying to think if there's any other devices that might be running that it would apply to. Yeah, I think that's it though.
Okay.
So you can write an app that can act kind of like an ACI, yes, to do a training, computer television. So I don't think, like, again, down to a computer, you would not be able to, unless you were using that computer as a server running like TFTP on it or FTP, I don't think your SDN would be managing, your SDN controller would be managing a computer. As far as ACLs, yes, you can control ACLs with an SDN controller for sure. We already know this, right? We know that the controller defines the data flows between the centralized control plane and the data plane, right? Because the controller is what's basically telling these devices what to do. Now, what the information that's going between these devices, they call it a flow, right? Each flow traveling through the network must first get permission from the SDN controller. Now that SDN controller can more or less give blanket permission once it's set up, okay? And it uses TLS to do that. So like what is TLS? I can't remember what TLS stands for, but kind of like a key. It's using like a key, okay? So that it knows that it's allowed. And thank you, the transport layer security. Yeah, so it'll have a key so that it knows that it is allowed. So this is the extra layer of security that having an SDN controller gives you that you don't have without an SDN controller. Now, can you still lock your network down without SDN? Yeah, you can absolutely lock your network down without SDN. SDN is just an additional layer of protection. And again, if you're running a hospital or you're running a medical facility and you're transporting medical files, this extra layer that SDN offers you with being able to implement specific security policies on top of AAS and TACAS and stuff would be very helpful and beneficial. And I'm sure that lots of companies are doing that. Oh, the other thing, Jim, you asked about the routers and the switches. Also, it would be any virtual routers and switches. So if you're running VMware, your SDN can run your VMware. You can implement that on your VMware too, whatever your virtual devices are. Okay. So again, we already know this too, right? All the complex functions are performed by the controller. So notice again here, the controller populates the flow tables. Okay, so because the controller is receiving the data from all of the different devices and it's getting policies that are supposed to be implemented, it'll say, okay, I just got this policy. So because I got this policy, I'm going to push this data down to that router or down to that switch. So within each switch, right, there's a series of tables. There's 3 different tables. Now these are different than MAC address tables, ARP tables, etc. Okay, or cache. Now there's still going to be ARP tables inside of our switch. But within the SDN program that is running on that device, that program, right, that part of that operating system, are going to host a flow table, a group table, and a meter table. Okay, and from there is how the switch is going to be forwarding out the information. Okay, so here, notice the meter table, okay? Because if the switch receives information from the controller to say limit something, it's doing that based on what information was pushed down to it from the controller, and now it's storing that information in the meter table, right? This table triggers a variety of performance-related actions on a flow, including the ability to rate, limit the traffic. So it can moderate bandwidth, speed, the number of frames that are going through at one time, the size of this number of bits that go through. That meter table, as a controller, I can tell it anything. I can make it do whatever I've written a program for it to do. So because SDN has the ability to have custom APIs, we can customize and make our networks really granular. So that would be another reason why a company may implement SDN if they need granular management of particular things. You could implement SDN and accomplish that through writing these programs, these APIs. So there's 3 different types of controllers. So this kind of goes back to your question, Justin. Okay, so there's a device-based SDN, right? That's where the devices are programmable by applications running on the device itself. Oh, one PK, sure enough. Or on a server in the network. So what they mean, so this right here, this would be like if I have a server in my network, and if I use 1PK, so 1PK is Cisco's application writing kit. Okay, so I can go subscribe to 1PK, and if I know how to write programs, I can write my own program. Okay, I can load that onto my server, right? So it's software based, but I put it on a device. And now I use that to control my devices. Okay, so it is device based, but notice I'm putting an application on a device that I have. I don't necessarily have to go buy a brand new device, but I have to run OpenFlow. So I have to put OpenFlow on that server, and then I write whatever my application programs are, my APIs, and then I can use that to manage my device. And remember, OpenFlow is a platform or an architecture, but it's also referring to the protocol that I have to run on this device and on this device, so that an OpenFlow Southbound API can communicate back and forth. Then we've got controller-based SDN. Now, controller-based SDN is just more of a traditional version of SDN, okay? It's going to be a little bit more expensive because you have to have a special device for your that you would put, so you buy the device, that device has the you need to put an SDN controller software on it. So you buy the device and you buy the software. And you buy the software based upon what you need it to do. Okay. And then you may even have to have your own software written. All right. You might have to do like Open Daylight and get something custom built for you, which is what, again, like a hospital, that's how they're going to have specialized software. And, you know, there's companies out there that write software, and then they'll go to the healthcare company and they'll say, hey, look, we've written this great program on how to manage hospital care, how to manage patient care, how to manage drug manufacturing, and how many, what you have in stock and what you don't have in stock. All of that can become part of your SDN platform. Okay, through the applications that are getting written. Okay. So notice here, we've got our physical device. We put our applications on there. Okay, this out interface with the controller, responsible for managing the devices and manipulating the traffic flows throughout the network. The Cisco Open SDN controller is the commercial distribution of Open Daylight. So again, Open Daylight is where, let's say I'm running a hospital and I'm a network administrator and I want to create my own APIs, I'll do Open Daylight. Cisco is Open Daylight, but it's the proprietary version, kind of like you have Linux and then you have Red Hat. Red Hat is Linux, it's just a proprietary commercial version of Linux, okay? Cisco Open SDN controller is the Cisco proprietary version of Open Daylight. Now, it uses OpenFlow for the Southbound APIs. So you have to be running OpenFlow on your SDN controller as well as your data plane. Now, you could run Netconf. I think OptiFlex is another Cisco one, but you got to run ones that will be compatible with Cisco. Okay, if you're using the Cisco Open SDN controller. Open Daylight, what does this say? Open source built on Linux. Okay, you can customize it and then resell it. So that's why I was saying, like, there's companies and there's people out there where they'll build something and then they'll go solicit it. Okay, so they'll say, oh, I'm going to build this for hospitals, and then they can even, you could take it to a hospital. So we do that. People come to the school all the time and say, hey, look what we've built. We've built this great student information system for maintaining grades, or for, people to request time off or whatever, right? That's what these are. So let's say I say, yeah, I want to buy that, but can you customize this little thing? I need it to do this. Sure, I can do that. Notice here, the Cisco OpenSDN controller, you need to know this. This will probably be on the CCNA. So we're possibly moving into an area where you'll have to know some of this stuff for the CCNA exam. Again, you definitely need to understand the difference between a northbound and a southbound API and interface as it relates to SDN. So the other thing you do want to know is that for Cisco Open SDN controller, that it centralizes most of the control plane on the controller, and it requires the switches and routers to support OpenFlow. Again, you can't just use any old switch and router. That's super important. So for a company that wants to run SDN, if they've already purchased a lot and invested a lot of money into routers and switches, this could be a really costly thing for them. It's just like us at the school. We've got that nice little lab, right? Well, let's say I wanted to implement SDN so we could start teaching SDN. None of my devices would be compatible with it. So I'd have to buy a $30,000 controller and then some $9,000 switches. So it's important to understand that about these. Okay, you've got to have routers and switches that will support OpenFlow. Our 2960s don't. It's possible that we bought some new 4321 routers. It's possible that they do. I don't remember. I might be able to upgrade them where I could buy a new iOS package that would accommodate SDN, but I don't know that for sure. Okay, so we see the difference between this one, right, and this one. Got the policy-based SDN. Now this is kind of Cisco's baby, if you will, all right? So it's similar to the controller-based SDN, where there's a centralized controller, right, that can look at everything, right? It's the all-knowing eye. It's policy-based SDN, okay? It includes an additional policy layer, so right here. And that falls between the controller and the application. It uses built-in applications that automate advanced configurations. So there's stuff that's built in, but you can add APIs, and it has a GUI, okay? Now notice what this says, no programming skills are required. Cisco did this, and again, this is new. Literally, I think APIC-EM, again, I think my timeline, if I'm not mistaken, is 2015. Cisco takes a look and they're like, oh my gosh, look at all of our customers that have all of these switches and all of these routers, and they want to be able to automate things, but they don't want to go buy a Nexus 9300. They don't want to have to buy this and buy that and upgrade and get rid of, okay? And what about my network administrators that don't know any programming, right? So that's why Cisco came up with the APIC-EM. Now, APIC-EM is different than APIC. So there's an APIC controller, which is just like more of a regular SDN controller. And then there's APIC-EM, the enterprise model, so that their clients could keep everything. They do still need an SDN controller though. So notice here, I can keep my traditional switches and routers. So I can keep my traditional routers and switches. I don't have to replace all my equipment, but I do still have a centralized controller. Okay, now the other thing that's a little different about this one, okay, is it does say data plane, data plane, data plane. The truth of the matter is with APIC-EM, it does not really remove the control plane and push it into the SDN controller. The SDN controller is still looking down at everything. The devices are still interacting with the controller, okay? They're still interacting with the controller, all right? However, they still have decision-making abilities on their own. They're following the direction of the controller. And so the devices are still making decisions, but the SDN is telling them what to decide. I don't know any other way to describe that. That the control plane is not removed, because look, we're still using our same old switches and routers, right? So it isn't removed. So it doesn't remove that ability of the decision making from the devices. However, it does more or less transfer control to the SDN controller, and the controller makes the decisions, and it's still telling the devices what to do. But the devices are implementing it a little bit differently than a device that doesn't have a control plane on it. Okay. Let's see. So the Cisco ACI centralizes most, but not all of the control plane. So this is, the Cisco ACI is basically the implementation of the data center application-centric infrastructure, right? It's all based on policy. Now, this is using the APIC, but not APIC-EM, okay? That's where the difference is. APIC-EM is the enterprise model for me as a company that doesn't want to make a big, huge investment and change everything. If I'm doing ACI, right, the platform of ACI, I could do one or the other. I could do APIC-EM, or I could just do regular APIC, okay? Because if you're looking here at ACI, notice how it says it centralizes most, but not all of the control plane. Okay, where do we go here? So that's like this guy. So the controller-based SDN. This is a more traditional way of doing SDN. Okay, so again, this is the APIC controller, but not the APIC-EM controller. Different. Okay, it's functioning more like the regular. So since I see OpFlex right here, what type of an API is OpFlex?
Southbound.
Southbound, exactly right, southbound. Okay, let's see, policy base. So here are my different policies, right? I've got to have special devices. So if you look right here, what devices, right? Nexus 9000. So I have to have specialized devices here. I cannot just have any old router and any old switch. And the Nexus 9000, those are going to be layer 3 switches, okay, that can function as a router or a switch, minus the control plane, because the APIC controller is going to be managing the control piece of decision making.
In this scenario, would we need a router? Would we still need a router?
Yeah, you still need a router, because you still are routing traffic. It's just that you're only routing the traffic based on the direction given to you by the APIC controller. But you still need routers in your network. You still need a layer 3 function. A layer 2 device still cannot move an IP packet. It can't forward an IP packet. Only routers forward IP packets. So you need a layer 3 device. And you need a layer 2 device for your LAN connect. So there's OpFlex, our southbound API. So it's saying here that some control plane in switches, I really don't know what it is that it's still functioning in the control plane. So I know that it's got, again, the flow tables, the meter table, the group table, and those tables are going to be filled based on whatever the controller is giving them. So I'm not sure what decision these switches are still making, but obviously here it says, right, centralize most but not all of the control. I don't know what piece of the control it isn't handing over to the controller, but something. So with the APIC-EM, right, so we're automating the network while keeping a hardware solution. Now, APIC and APIC-EM, we can keep a hardware solution. APIC-EM, though, allows us to keep our existing hardware, okay? So there's three primary things that make up the Cisco ACI, the application network, right? So here's all of the different applications that we've got going on. The fabric, okay, so we're going to hear this term fabric. Fabric is basically APIs, a combination of the API/media, right? Whatever it is that allows the devices to connect together is creating a fabric. Stateless hardware, okay, so in other words, it doesn't matter where it is, what it's doing, because it's being told what to do. So it's stateless. It doesn't have a preconceived idea of what it's capable of or not capable of. Okay, so for an APIC-EM controller, right? So the APIC-EM, it's specific to Cisco. It does use an APIC-EM controller. So even if you want to use your existing switches and routers, you do have to invest in the APIC-EM controller, as well as the software for the controller and the devices, because the devices need a way to still communicate back and forth. Okay. You can also use SNMP. It tells us here too. We can use Telnet, SSH, right? You could use FTP and TFTP. So you can use several different things. You're able to maintain more of a traditional network, but add some automation to it and some programmability to it. So Cisco gives you a bunch of stuff that's already pre-built into the APIC-EM controller, and then you can also customize it. And which controller? Okay, and same here. So if you notice, the APIC-EM controller, it's already going to have the applications on the controller that allow you to control the routers and switches, as well as decide which southbound API you're going to use to send and receive data and information. The controller has RESTful northbound APIs that can make available that collected information about the entire network. So we're going to talk more about REST APIs in the next class. Basically, what REST APIs are is that the APIs are residing someplace else, okay? The APIs are residing someplace else, and we're accessing them versus directly in our domain with what I have access to where my normal northbound applications would be. Okay. So the control and data planes of the network devices remain unchanged, right? So that's because we're using our existing devices. So those devices still keep their control. It's just that the controller is telling them what to do. Topology, many devices. Okay, so it's the same. We can run any topology, several different types of device models. So our 3560s, our 2960s. I can use the CLI. I can use Telnet, SSH, SNMP. They also provide a GUI, okay? Then the APIC-EM will have some core features. All right, it's got some core features. Now, some of those core features is it has something called topology visualization. Topology visualization lets us see what my topology looks like. It will literally draw the topology. Why? Because it uses CDP, right? It's going to use CDP. Path trace. So path trace is something that allows us to check the path that a packet or a frame will take under normal circumstances, or if I apply a filter to it, like an access control list. So one of the benefits of running APIC-EM is it eases up a network administrator's workload because you get automation, right? Again, the whole goal of APIC-EM and SDN is to implement some automation. So now we can also build and control, we can build out an access control list in our APIC-EM controller, do a path trace on it, see if it's going to work, then we push it out through the controller to the devices. Okay, so again, it's kind of centralizing everything so I don't have to go into my individual devices. So if I needed to add an access control list for SSH onto every device, well, I could do that on my controller and then just push it out to the devices. Our current old-fashioned way, you got to go into the switch, do the access control list for SSH, go into the next switch, add the access control list for SSH, go into the next switch, add access. You see what I mean? Okay. Let's see. Easier network. Let's just see what these say here. Make sure we're not missing anything. The APIC-EM will gather information about your network over the SBI. Because why? The devices are still communicating to the controller, right? Each device is controlling using my Southbound interfaces, my SBI, so OpenFlow, OpenStack, whatever it is I'm using, NetComp. Let's see. It'll make the information available through extensive northbound, so it will push that information up, right? So that policies can be built. Makes the devices still change how the devices are changing the configuration. Okay. APIC-EM can still change how the devices operate by changing the configuration of the devices. You do not lose the ability to go into the device and make a change because it still has its brain. However, like my previous example, you can use the controller to do that. So you still have both, but you can use the APIC-EM to change how the devices operate, okay? Okay, it says SBIs include the CLI, okay? So we can still access everything. Now you can actually set your controller up so that you can access it remotely and then make all your changes through your controller, or you could do it the old-fashioned way. SNMP as the Southbound. So again, I can also use SNMP. We're maintaining what we had, but we're gaining, right? We're kind of getting the best of both worlds with Cisco APIC-EM. Okay, we're starting to wind down here. We're getting to the end. Okay, so we've got the ACI spine leaf topology here. And this is going to function whether I'm running APIC, APIC-EM. Okay, this is the traditional way of setting up an SDN platform. Okay, now notice here we're using the Cisco 9000 series switches, so we're running a traditional APIC here, not APIC-EM, okay? So the key to what a spine leaf is the way that the devices are connected. And it's the way they're connected using the actual media, okay? So the media. And if you look here, notice that none of these switches are connected to each other, right? They're not connected to each other. None of these layer 3 devices are connected to each other. That is what makes this a spine leaf, okay? And spine leaf is a term that applies more to an SDN platform than any other kind of platform. So if we look right here, the spine is our layer 3 devices, okay? That's running in the middle here. Then we've got our switches, our end devices. Now these switches, they're traditional switches. Okay, they're not a layer, these are layer 3 switches. So these are functioning right here as our router. Okay, now they may be doing a switching function as well, but more than anything, they're functioning as a router. Okay. So if we look at this here, leaf switches attached to the spine. Okay. Now, a standard leaf is the switch that's connecting to our end devices on whatever domain it is that I'm controlling, user domain, right? My application, my people, my access layer. This is my access layer. Okay, so a leaf switch, again, it's just whatever the switch is that's connected to my access layer. And they're not going to attach to each other. Leaf switches are always going to attach to the spine. A spine is typically going to be a layer 3 device. And the spine, they also do not connect to each other. Okay. So I don't know if this will help, but right, if we look at this like a leaf, because then we've got the border leaf, right? The border leaf are going to be our edge routers or our edge devices. So this is kind of like a leaf, right? And we've got all these guys. Because on a leaf, these spines never touch each other, right? They always just go out. So you don't have a spine that goes like this, right? So I don't know if that's how they came up with that or not, but that's how I kind of think about it. Okay. And then up here is going to be my data center. So here might be where I've got, or whatever, you know, maybe I've got my own data center, but this is where I'm going to run my apps and have my policies, where I'll be storing my policies. Let's see. When compared to SDN, so I think this is the APIC-EM. When compared to SDN, the APIC controller does not manipulate the data path directly. Oh no, it could be APIC or APIC-EM. The APIC controller does not manipulate the data path directly. Instead, the APIC centralizes the policy definition and programs the leaf switches to forward traffic based on the defined policies. So actually, I believe this could be APIC or APIC-EM. With SDN, like the open daylight controller, it's making all of the decisions, right? And here, the APIC is using the policies and then pushing that information out. Again, to me, it's a slight difference. It's hard to imagine, again, whatever that slight variation that's happening. Let's see. Oh, my roommate's boss is under quarantine because her daughter works with someone who has COVID. Oh, that sucks. Okay. So again, spine leaf, that's what it is. I don't know for sure. Chris Jones, are you on? Did they ask you anything about spine leaf?
No. Talk anything about spine leaf.
I think spine leaf technology and spine leaf topology is probably something that will be in the new CCNP, but I can't swear to that. Can't swear to that. All right, so then again, we just have a couple more pages left. I know this is kind of long. So again, remember APIC-EM, that lets me keep my services, right? Keep all my old-fashioned routers and switches. And it has some built-in apps that are super handy. Okay, so it can discover and access devices and keep an inventory, right? It'll build a topology for you. You can actually tell it if you want it to build you a logical topology, a physical topology. Now, if you want it to build you a physical topology, you either have to have descriptions on there or you need to go in after the fact and add some information. Okay, but it'll build out whatever you want. Okay, and then it'll trace path between endpoints. And then it will help you implement policies like filtering, access control lists, SSH, things like that. So another one of the APIC-EM apps. Now you can get apps like this for any of the controllers, okay? APIC-EM comes with these built into it. So you will probably need to know these apps for the CCNA, the new CCNA, okay? So again, Cisco likes APIC-EM a lot, right? So Path trace is an app that will predict what happens in the data plane of various devices in the network. So it will predict what's going to happen if a packet comes into an interface on a router. Like what interface will it go out of? Will it get dropped? Is there a gateway of last resort set? It can figure that out. It can predict it, okay? And it can do that because the controller, the APIC-EM, it knows what routing protocol you're running. Are you running OSPF? Are you running EIGRP? Are you running RIP? It knows that. It's able to make decisions about the algorithm, okay? Before using path trace, another app called Discovery discovers the network topology. So that's what this one is. This is Discovery. Okay. The path trace app examines information pulled by the APIC-EM from the devices in the network, right? So it's using the Southbound APIs, getting information, what's in the MAC tables, the routing tables. So remember, we're using our regular devices, so we haven't split the data and the control planes, okay? Other forwarding details. So it's also going to have access to the topology tables, the neighbor tables, all that stuff. Okay, and then it can analyze where an imaginary packet would flow. Now, we could do that too, right? We could figure all that out, but it would be tough because we got to draw everything out. We have to figure out what our link speeds are, et cetera, et cetera. So then the path trace GUI, right? I click on the app, it'll display the path. And then it will put it on our map. And you can make this map as detailed as you want. So let's see. Allows easily visualize the traffic. So again, here, easily visualize the traffic, discover any conflicting, duplicate, or shadowed ACL entries. You know, ACLs can become a real bear and a real nemesis, you know, especially when you have lots of entries for your ACL. Well, path trace can help you do all that because you can pick up your packet, drop it at your source, and tell it where you want its destination, and then it will check to see if it's got any of these problems, okay? This tool will examine specific ACLs on the path between the end nodes, displaying any issues. Along the path, permitted. Notice how branch router 2 is permit all traffic, okay. So then you can make adjustments. Now you still have to write the access control list, and then put it into the controller and push it down to your device. So you're still having to function as a network administrator. Let's see. Path trace analysis tool, the ACL depends on. So the ACL analysis tool, which is another app, depends on the path trace app. So you have to have both, okay? It extends the function of the path trace. Path trace doesn't consider ACLs, okay? This enhancement allows for the consideration of ACLs along the path. Yeah, so if you're gonna run, if you wanna do an ACL analysis, you have to have path trace. And you have to run the path trace first, then you can do the ACL analysis, right? Which of the following controllers, if any, from Cisco uses a mostly centralized control plane model? Mostly centralized. It's like traceroute. However, it is actually not traceroute. It's its own protocol. And yes, it would be similar to what Packet Tracer does. Exactly right. Mostly centralized control plane. So not all. A, the Cisco Open SDN controller. So remember, traditional SDN controllers, non-Cisco, are the ones that are all control plane based. So pretty much Although I guess the APIC is going to be a traditional, that's more like their traditional SDN implementation of SDN. APIC-EM isn't, right? Because it doesn't separate it at all. Cisco Open SDN is mostly, right? So if we were to go back, this guy, not AM, central, so Cisco ACA centralizes most, but not all of the control, right? That's just a typical, and there was another place, hold on, that actually, I didn't want to keep it, let me find it. Controller based, right? Controller based. Cisco Open SDN controller centralizes most of the control plane on the controller and requires switches and routers to support OpenFlow. Oh, you know what? That's probably why it's most and not all, because it requires switches and routers to support OpenFlow, which means they have to have a little bit of a brain in order to support it. So I bet that's why it doesn't give up everything. APIC-EM, it doesn't separate the control plane and the data plane, right? But the controller can still make decisions and tell the devices what to do. It's just that the devices maintain their brain. Let's see, host A and host B sit in two different subnets. The path between the subnets of these two hosts runs through three different layer 3 forwarding devices, routers and layer 3 switches. A network engineer uses the APIC-EM path trace ACL analysis tool to analyze the path used for host A to send packets to host B. Which part of the function is done specifically by the ACL analysis or ACL trace part of the tool? And this is a CCNA question. Host A and host B sit in two different subnets. Okay. Path between the subnets of these two hosts runs through three different layer 3 forwarding devices. Got it. A network engineer uses APIC-EM path trace ACL analysis tool to analyze the path used for host A to send packets to host B. Which part of the function is done specifically? Okay, so discovery, no. Analysis of the layer 3 forwarding decisions in the path. Analysis of the layer 2 forwarding decisions. Analysis of the impact of the ACLs on the packets that would flow from host A to host B. Yikes. So C, D, B, C. Oh my goodness. Okay. Path trace AC. Okay, so remember we have to run the path trace first, then we can do the ACL analysis. Discovery would already had to have been done to analyze the path used for host A to send packets to host B. Which part of the function is done by the ACL analysis or trace part? Forwarding decisions in the path of the layer. Okay, so I'm going to say B, but I'm not sure. Okay, and the reason I'm saying B, well, analysis, hold on. Analysis of layer 3 forwarding decisions. Hold on. Analysis of the impact of ACLs. Oh, that would flow. You know what, Justin, you might be right. It might be D. Analysis of the impact of ACLs on the packets. So the reason I'm not picking C is because we're on two different subnets. So we have to go from one network to another network. I had said B, analysis, because, okay, so B might just be path trace, right? That's just path trace. That isn't an analyzing an ACL. So Justin, I think D might be right. All right, let's see. What? Who got it right? Did anybody pick A?
Nobody picked A.
Oh my gosh. What?
Didn't it just say that it doesn't, before this, it said it doesn't do the topology?
Let's see.
It has to have the path trace first to do the topology.
Let's read what it says again. Okay. ACL analysis tool app depends on the path trace app. It extends the function of the path trace app. Path trace
Doesn't consider
doesn't
ACL.
consider ACLs. This enhancement, okay, so the ACL analysis tool, this enhancement allows for the consideration of ACLs along the path. This okay, so then what's the question? Post haste. Path trace. Oh, path, okay. So it's using,
Question.
I don't
Questions
get
need
it.
to be, do questions need to be this complicated? Oh my God.
Yeah, I mean, because I think I look at this and I say,
Yes, we will.
okay, APIC-EM they already had to run path trace. And now it's using the extension, path trace ACL analysis tool, to analyze the path. Yeah, yeah, I don't know. I guess if I would have missed this because I would have looked at this ACL and maybe this is the important part, to analyze the path used for host A to send packets to host B. And that would be discovery of the
The function is
topology
done
that
specifically.
exists.
ACL
I don't know,
analysis
I would have missed it.
is part of the tool. Yeah.
I mean, I didn't even think A.
Next.
Yeah, my brain hurts now.
Yeah, I'm pretty sure that the ACL analysis tool is actually only on the ACLs. I don't think that the topology is built from specifically that tool. From the entirety of the path trace application, I think that would be right. But since it's specifically asking what function by the ACL analysis or the ACL trace part, I don't think it's the full topology that pops up on that. I'm looking it up right now, but the book doesn't actually say anything specifically on the ACL analysis or the ACL trace um, tool specifically.
So this is the kind of question that you will have on the CCNA that again, the book, our reading material, right? It just isn't detailed enough for us to understand these apps, but these are exactly the kinds of questions that are on the CCNA. Let's see. So this is just comparing OpenSDN to ACI to APIC Enterprise, right? Changes how the device control plane works. OpenSDN does yes. ACI does yes, but APIC-EM does not. Creates a centralized point from which humans can automate. That's a yes on everything. Degree to which the architecture centralizes the control plane. OpenSDN mostly. ACI, again, it's it's a lot of it. It's saying partially here. That's just because it's a little bit less than mostly. APIC-EM doesn't. SBIs are used, yep, on all of them. They have different ones. And actually, you can use OpenFlow on APIC-EM too. Controllers mentioned in this chapter, Open Daylight, Cisco OSC, APIC, APIC-EM, organization that is primary, ONF, Cisco. Okay. What is the primary advantage of APIC-EM?
You're able to keep your current infrastructure.
Yeah. And let's see, you can keep your current infrastructure so you could save money. It has a GUI, so you don't have to know as much programming, right? So there's a couple of advantages. ACL path trace should do that. Yeah, okay.
Meaning it should show the topology.
Yep, you can show the topology. Now, your other controllers can do that too, but you have to add that application, whereas APIC-EM, it's automatically an application. So like Cisco's giving you this user-friendly apps already, kind of like a cell phone or a computer, right? You go buy a laptop and they've graciously already added the Microsoft suite on there for you, or a TV, it now has Hulu and Yahoo or YouTube on it, etc. Right? They're helping you out. I think that's it, guys. We already answered those questions. We did those. Southbound interface type. Okay. Okay.